Now I want to take a minute to talk about how you work on these boards. The circuit board that we're working on right now is a very difficult one to service. It is not a multi-layered board. It is a double-sided board, but it has a lot of the challenges that a multi-layered circuit board would have, and that is the little pads where the components attach. Let's go back here for a second. Are so tiny, and the leads the holes are just large enough for the leads to go through, which is fine. That's actually a good thing. But it makes it very difficult to desolder these. If you put too much heat onto the board, it will cause the track to burn up and come loose because they're so thin and tiny, because there's so much going on in this tiny little compact board. If you don't get enough heat, you'll have too much dwell time on there, and again, you could lift the pad off. You have to have just that perfect balance of heat. The other thing is you have to have a good desoldering device. Even I was started out here showing you this. This is what I use, and I'm not endorsing this in any way, but a desoldering station like this is very helpful. I won't say it's 100% necessary, but it's very helpful in removing these components. Solder braid can work a little bit. You have to be careful with it because once again you can overheat the track and lift it and rub the track off by moving, the solder wick around. Although I do use this to clean up some of the mess, left over on the pads, but you have to be very careful. Put flux on the joint before you desolder it. It helps the heat to transfer to the solder and cleans up the joint a little bit, deoxidizes it a little bit so you can get a better thermal transfer and be quicker. The tip size if you do have a desoldering station, the tip size is really important. And you can see this one is very tiny. This is a small tip. There are multiple tips you can get for these, not just this Hacko one, but any one you buy, even the less expensive ones you get on eBay and so forth. But you see this tip here is a larger diameter, and what I will tell you is if you use this, it won't make proper contact with these tiny little solder joints, and it will actually not properly heat them, and it'll burn the trace off. You see the size of that there versus the size of the component that you're removing, or the pad joint that you're removing. This will actually cause it to burn the trace up, believe it or not. All these things are important, and if you're going to work on these things a lot, you really need to have the right tool for the job. This is a big investment. Even the cheap eBay ones are a lot of money for something that you may not use a whole lot if you don't do this on a daily basis. An alternative would be to use, a little desoldering pump, which, do I have a small one here? Yeah, I do. I'll show you. This would be something like this, and they have these little neoprene or whatever they are, silicone piece of tubing on the front. These will work, but the problem is the joint is so tiny that as soon as you remove the tip away to put this on and hit it, it's already starting to cool. So what will happen is you may pull the solder off one side, but it won't pull it all the way through the joint because this is double-sided, remember? So like, for instance, if I'm removing this resistor, I pull some solder off of this side, it might look clean on this side, but this side is not. As soon as you start pulling on this, you will lift that trace off the front. So you really need the correct tool for the job. Again, you can use other methods, but you just have to really practice on a board you don't care about before you start to do this. Now, if you have the right tool, it's actually not a bad problem. Of all of these that I've done so far, and you can see how many, look at these two CD4051s I've replaced. Gold star. These are old stock from when I used to work on these things, out in the field many, many, many years ago. I worked on, x-ray equipment. I used to buy those gym packs and things in the electronic parts house. But I had a couple. Thankfully, I didn't have to order them because They're not always in stock everywhere anymore. But anyway, I'll do one of these so you can see how it goes. We're going to, while I'm in here, I'm also going to put this one up on a socket and replace it as well. It is I believe this chip is okay. This is IC19, which is, where is it? Which happens to be this chip right here. You can see, and again, I don't think it's bad, but I am in here, and I am not going to be in a position where I have to put these up on boards all the time anymore. This is the business end of this, where all of the signals pass through and are controlled. Things like this I'm not as worried about, because these are like for the display drivers and so forth. So I'm not going to worry about these as much. I don't think they're in a position where they're going to be exposed to crazy voltages and things. These ones here, it's possible. So I'm going to put them up on sockets because I can, and because I have the components and I have the ability right now that it's a part. Okay. Things like these TLO84s, TLO82, TLO81, all of those, they tend to fail, at least in my experience. So again, I'll put them up on sockets so that they're easy to replace in the future if something fails. Now, if you don't have the proper tools to do this, I would not recommend you do that, because you could actually damage the board and cause problems, when it's not necessary. So let's demonstrate replacing this chip. Okay, so first thing I'm going to do is I'm just going to take a Flux Pen, just a plain old Flux Pen, and I'm just going to put a little bit of flux on these joints, so that when we put the desoldering unit on there, it'll heat up much faster and help remove the flux, or remove the solder much quicker, or more quickly, for all you grammar nannies. You want to always clean the tip and keep it clean. Alright, we're just going to go in like this. It heats it up very quickly, and you can see it removes very, very quickly, removes all the solder off there. So I'm having a hard time seeing around the camera here, but you see how you want to get a seal over that joint and move the lead around once the solder liquefies. See? And then what I will do before I try to lift this off the board is I'll inspect each individual solder joint and make sure they're completely out. If it's not, I'll reflow some fresh solder on there and I'll try again. I can't see what I'm doing here. I need my bench glasses on. I didn't put them on this morning before I started. There you have it. Clean the tip again. Actually, you should clean the tip before you start, not before you put the thing down, because it's kind of good to leave a little bit of solder on the tip. It helps prevent the tip from oxidizing and getting damaged. So now you can see, let's put some light on the subject here. So now you can kind of see, where am I here? Right here. If you look, what I'm looking for is, I want to see no solder pooled up on the top part of the joint all the way around. If I see that anywhere, it looks like these ones are pretty clean, I will try to lift it off the board, and it should not give you a lot of resistance. If it gives you a lot of resistance, stop. Don't force it. And you have to inspect it a little more carefully. Now I use these little solder assist tools. They come in different shapes and sizes. You can also use things like the dental picks for dental tools. And they really help a lot when trying to remove these components from the boards like that, see? So I've been using this little hook, and see, that popped right off. And let's see if this side pops. And it feels like there must be one on this side that's still tight. I don't know if you could see if I'm in frame. So on this side, there's still a little bit tight. This side's open. This side, we have at least one that's not completely released. So I'm going to have to look at this very closely under here. I'll back up so I don't keep going off frame. And I'll look here very carefully, if I can, you can see. And I'll try to find out which one is not releasing. That one's loose. That one feels a little bit tight, so I have to remember that. That one seems loose. So that one's very tight. So we're going to go through and we're going to reflow these couple here, because you don't have enough solder to get on it. And that one's loose. 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 And loose. So what I'll do is I'll reflow those couple of joints there, and we'll desolder them and then try again. You have to be patient. If you don't do this, you're going to damage these traces. And you can see the way this board is, it doesn't really have a coating of flux or any conformal coating or anything like that on it. And when you clean this with alcohol, you can see it kind of smears the flux around. So we can either coat this with something when we're done, or we can use flux remover spray, and if we want to make it really, really neat. This won't hurt anything, it just kind of looks weird. So I know I'm ambling on here, but let's reflow this now. Alright, I'm leaving this in the video because you can see how easy it is to do this. See how these are all spaced? I desoldered the wrong chip. I desoldered this socket on this side. These ones weren't desoldered. That's why they're not coming out. What an idiot. Okay, let's take two. I'm sure you will all get a nice chuckle out of that. So we're going to put our desoldering braid on there, and let's take two. What do you think? Do I have the right one this time? I sure hope so. This is so hard looking around this camera. My shoulder is literally touching the camera right now. And my chin is almost touching the viewfinder of the camera. But hopefully you all can see what I'm doing. Come on. See, the whole chip is moving already. See it? We got it. So it helps to desolder the correct leads as well. There you go, and there's your chip. Alright, now the next thing I do is I inspect the pads, and notice there's really no solder blobs on them anywhere there, and I want to check the bottom as well and make sure they're all cleaned off. If they're clean, then no need to do anything else. If they're not clean, you would take some solder wick and more of the Flux Pen and clean that off and just go over and just sop up any mess. But don't do that unless you have to, because look how tiny those traces are. It'd be very easy, again, to lift a trace. Now I will take some alcohol and I will thoroughly clean this area and get rid of any substance, flux, whatever. I want it to look neat, and I might as well fix this side too, because I did such a nice job of desoldering that socket. I can't believe it. Well, yeah, I can believe I did that. This is just life, you know? Alright. Hey, if you can't get a good chuckle out of life once in a while, what the heck, you know? Okay. So let me get a socket. I'll have to dig one of those up, and I will get another 74 HC374. Where is it? Under here. 74 HC374. Alright. I'll be right back. Okay, here's our new 74 HC374, and yes, it says CD in front of it. I think the old one was MC. This one was made by Motorola. This one was made by Texas Instruments. That's why it says CD versus MC. You will find that there are certain patterns to chip nomenclature that you'll start to learn what they mean and which ones are interchangeable. They're identical, it's just they're made by a different manufacturer. The 74 and so forth, that part is the important part. 74 HC374. And sometimes, like with Motorola, they'll take like a 4000 series chip, like a, you know, like this is a 4051, okay? This would be the same as a CD 4051, but Motorola says MC14051. That is a 4051 chip, is what we refer to it as. So just some things to remember. There are interchangeable parts. You don't necessarily have to have the MC whatever. You can get the CD one, just different manufacturer. All right, talking about sockets here. While my wife and daughter practice flute upstairs and give us a little serenade, I guess. So there's several different types of sockets, one of which I do not own, and if I get them, I just throw them away. I don't even use them. So the first type is this very basic socket. And you can see the pins are very flat. And let me see here. So the pins are kind of flat looking and thin, and they're sealed all the way up inside here. So you can see there's no opening on the plastic in here. It's just molded right around them. That's a good thing, and I'll tell you why here in a minute. On the other side, if you look at these pins, so you have the spring part on this side, and you have a contact on this side. So when you put the chip into the socket, you know, when you go to plug it in like that, what ends up happening is this spring presses the contact of the IC right against the contact on this side. So essentially it's touching on both sides. And sometimes you can push these out to actually see what they look like, but it's not real easy to do. There goes one. And you can see the pin looks like this. So it's kind of a little spring. I don't know if you can see that or not. And when you put the chip in there, it kind of squeezes in between there and there. It makes a really good contact. These are the kind you want to use, or at least one of the type you want to use, because they contact the pin on both sides. Now they make another version of this where it only has the spring side, meaning that you only have the contact on this side, this springed out part, and there's nothing on this side, and it only makes contact with the IC pin on one side. Those are bad. They seem to wear out and don't make good contact. They come loose. These ones hold pretty good. Now another thing you have to watch, especially with these kinds of pins like this that contact on both sides, if you heat these up too much, and some of these have more of a gap, they have like a snapped in pin on this side, and when you solder these in here, the solder will actually wick right up this leg, and it'll actually fill these pins in. So you'll go to put your chip in and it won't go in. You have to be aware of that. So when you solder these sockets in, you want to make sure you get the solder on there and get get away from it. Don't sit there and dwell on it and hold 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 it until all the solder fills up the pins. So that's just a little tip. The other type are these solid cylindrical pins, and you can see the way they look. They're all filled in, so there's no chance of, you know, the solder wicking its way up inside the socket area. And on the front, the pins are round instead of square, but they still make very good contact. And these are very high quality pins or sockets. They hold the socket up off the board. They have this little shoulder on them, and we used to use these a lot. They're very good quality because there's nothing to bend or to loosen or to, you know, they always make good contact. Now, if you ever, the other one here, this is just like this one, but these are much higher end. They're more expensive, and they have a thicker, you can see a much heavier duty, thicker pin on them. The tabs are silver plated instead of kind of chromed like those other ones were. And these are really good sockets. I only have a couple of these because I've used most of them up. And last but not least, there's these little terminal strips you can buy in bulk, you know, from Amazon or eBay or whatever. And believe it or not, they are the same sized pin as these. And all you do is you can just break off the length that you need. And if you need a makeshift socket, you can see they work very well. So here's one I used with those little strips, and here's an actual socket. And this is one of the cylindrical type like this that's in here. So I just thought you'd like to see that. Okay, now that everything's cleaned up, let's put the socket in. And what I like to do is I'll hold the socket down. These ones have solid pins. They're not tabs. They're cylindrical pins, and they don't bend over. So you really, in order to get it in there, you're going to have to tack solder at least one of them in there, which is what I'm going to do here. And everybody has their own little crazy method of doing it. This is how I do it. I just hold the solder next to there, and you just need one pin to be in there to hold it. And there it is. Sometimes you can also use a piece of tape or blue tack or something to hold the component. There's many different ways to do it, but that's how I do it. So I'm going to go through, and I'm just going to, first let's fix the one that we didn't need to desolder, and we'll just pretend that never happened. What do you think? And this is all, you know, you're kind of going blind. It's so tiny, and if you're not using a microscope or something while you do this, you're just going to have to flow these on there by feel, and, you know, as best you can, and then go through and inspect your work when you're done, you know, with a magnifying glass or something when you don't have both hands tied up. And then you may have to go through and fix whatever one you didn't get right. Again, I'm kind of giving you a lot of information here, but a lot of the modern equipment doesn't use through-hole components like this. And this type of soldering, really, they don't teach it a lot anymore. And or you may not get a chance to do this very often. And when you do run into a situation, and boy, there we go. You want to know what you're doing here. So there you go. You can see the flux is on there. We'll clean that off with a fresh cotton swab. And I like to use the ones for makeup, not the ones you clean your ear with or whatever, you know, because these have a lot tighter cotton on them. They don't tend to fray out as much and leave little particles of, you know, cotton bud all over the place. And I'll just go and clean that, and it'll still leave a smear mark there, but it'll clean off the big stuff. And there you go. Okay. Now we're going to, now that it's cleaned off, we can inspect it. And I always hold it at an angle. I don't know. how well you can see in the camera, but I have that light on there, and those all look perfect. What I'm looking for is I want a nice shiny solder joint. It should be conical. You don't want any kind of blobs. And it should come up to a point, like right at the top of the lead. And those all look like that, so that's good. There's a little piece of fuzz on there. We'll clean that off. Okay. Flip it over. Everything looks good. You want to make sure when you put your socket in that the notch of the socket matches the notch, if there's a silk screen on the board, that it matches that, because the notch indicates pin 1. So if you're looking with the notch on your left, pin 1 is down here at the bottom. You know, most chips will have this little dimple. That's pin 1, and it goes 1, 2, 3, 4, 5, 6, 7 all the way around, and then it makes a loop. So this is 10, 11, 12, 13, 14, 15, 16, all the way to pin 20. So you read the pins like that. All right, let's plug the chip in. And what you're going to find is the way these come, the pins are splayed out at an angle, kind of like that. And they're not going to fit in the socket. They're wider than the socket. So if I try to plug this in right now, you can see if I line up this side, it overhangs by a good bit on this side. So what I want to do is I want to straighten that out before I put it in. All right. I may carve this out as a separate video, how to remove and replace these chips. And what you're going to do is lay it on a flat, hard surface, and you're just going to roll the chip gently like that until they're square. Now it's going to make it a lot easier to get these pins in there, or you're going to be trying to fight, especially these big 20-pin chips, and even worse, the 40-pin chips. You can see they just fall right into place now, even when you put it in backwards like I'm doing. All right, there we go. And see, it just pops right in, and now you just gently rock it back and forth and push it in. There it is. And they make little tools that will extract and insert chips like that. And the tools actually have 2 flat parts. I have them somewhere, and Lord knows where I put them because I never use them. But they actually will square up the chips like that and allow you to insert it. And they also have ones with little claws that come in and grab the front and rear of the chip and let you extract it. I used to use those at work once in a while, but when I used to do massive, we would have boards that would have massive chip failures where, 20 chips would go bad on a board. And the board would be one of those, they only made so many of them because it's such a rare piece of X-ray equipment, and you had no alternative but to replace the chips. And a lot of the boards, the manufacturers would put the chips up on sockets, so it'd be easy to replace. A few of them, you'd have to do this desoldering thing, and it was very difficult in the field because we didn't have workstations like that. And you had to do it with solder braid, and it was very difficult. And in those cases, we would just cut off the pins, and we would just pull each pin out separately as we heated it up, and then clean it off with solder wick. Just be done with it, and then put sockets in after that. Anyway, enough talk about that. So that one's in. I'm going to go through and do a couple more components on here, and I am going to replace these relays. I tested them, and they seem to be working properly, but they are a point of failure. I have a brand new set of them, so I am going to replace them, and just for future-proofing this thing. Okay, I know I will get yelled at if I don't throw this in with this chip replacement video, and that is, if you look at this chip, this is a 4051 or an LC-102. We talked about the nomenclature on it a little bit earlier, but a lot of these chips are static sensitive. Some of them are not, some of them are. For instance, these ones aren't too bad. Okay, you can damage them, but they're not too bad. But when you start getting into the 74LS series, low power Schottky and so forth, those chips are very static sensitive. And if you don't ground yourself, the static electricity that your body builds up, especially if you're standing on carpet, or if you're wearing clothing that can get static on it, you can actually damage the chip just by handling it. So it's a good practice to, number one, if you look on my desoldering station, and I didn't show this in the video, but you can see right here, it has a provision for an anti-static strap, and you can put that on when you work, and that will, this is connected directly to earth ground, and it just makes sure that you are discharged and that you can't put any static into the chips and damage them. But you can look that up online. There's lots of information about it, but I do want to warn you, just be careful when working with, especially with CMOS and with this, like the 74LS series integrated circuits. And after it's cleaned up, it'll look something like this. And what I use to get the flux off of there is I use this flux remover, and it gets all that crusty, nasty stuff off of there. You have to use this outside. You need to wear gloves. It's really, really flammable and smelly and all that stuff. So use it outside, clean the flux off, and then you can just leave the board dry like this. You can take, another trick that I use sometimes is I'll take rosin and I'll mix it in a bottle, like 50-50, or even cut it even harder than that, with alcohol, with, you know, denatured alcohol, or isopropyl alcohol I should say, and mix it real well, shake it real well, and spray it on there, or it's, you know, lay it on there, and then just kind of spread it out with a brush and let it level, self-level, and when it dries you'll get that shiny coating that you see on a lot of the stereos and, you know, equipment from that time. And then the other thing you can do, it's more permanent, would be to use this acrylic lacquer conformal coating, and they make it in green, and they make, this is clear, I believe is what this one is, and you can spray that on there, and just understand that will actually put a coating, like a paint, like a lacquer coating over top of everything. So if you need to solder on the board, it'll make it kind of difficult because you have to burn through that lacquer before you can get to the solder to work on it. So just, that's a little bit of more of a permanent approach. And if you're gonna, if the boards are going to be exposed to humidity or to outdoors or something like that, you want to do that. But if not, you know, just clean it off and make it look good. All right, I'm going to get this mounted back up, and that's it for right now. So I'm going to, the next video, we're going to kind of pick up where we left off with our project and see if this thing works, and go from there.